Hi, and welcome to the videos for section 2.5 for Math 126. This is the first of 3 videos for this section. In this section, we're going to be looking at transformations of functions. And specifically, what we're going to be looking at is how these various transformations affect the graphs. So vertical and horizontal shifts, expanding and shrinking, reflecting across the x-axis or the y-axis. That's what we're going to be doing in this section. The first video, we're going to be looking at shifting, either moving the graph up and down or moving it left or right. So first we're going to look at vertical shifts. So let's say I have the function f of x is equal to x squared. So we know from previous videos, previous problems, this is what? This is the graph of a parabola that goes through the origin. Now, let's say I have a function, let's call it g of x to distinguish it, and this is x squared plus 2. How can I graph this? Well, what's our basic go-to? Plotting points, right? So let's say I have -2, -1, 0, 1, 2, just as we were doing in earlier videos. If x is -2, what do I have? -2 squared is 4 plus 2 is 6. -1 squared is 1 plus 2 is 3. 0 squared plus 2 is 2. 1 squared plus 2 is 3. 2 squared is 4 plus 2 is 6. So that would give me what? So at -2, I'm at positive 6. -1, I'm at 3. At 0, I'm at 2, and then I start curving back up. So what is it? It's this same parabola, but what happened to it? Well, because I have this plus 2, let's call it for now outside of the function, and you'll see later when I talk about inside or outside, but because it's this plus 2, this is the vertical shift. It's moving it up 2 units. So it just took this basic curve of the x squared and slid it up 2 units. So then if I had, let's say, h of x equals x squared minus 1, well, what would you think that this does? Again, because this minus 1 is hanging off at the end here, this means it's my vertical shift. And because it's -1, it means I'm going to go down 1 unit. So without having to plot points, as long as I know what the basic function is, x squared, which is a parabola, it's just going to slide this whole thing down, but it's still going to have the same parabola shape, just shifted it down 1 unit. So that's my vertical shift. So to put it into verbal terms here, first, let's assume our value c is positive. So to graph y equals our function plus c, then we just shift the function f of x, or y equals f of x, up c units. So whatever my base function is, my base function is x squared. If c is positive, I move it up that many units. And similarly to graph y equals f of x minus c, then we just shift whatever this base function is, f of x, down c units. So that's our vertical shift. Let's look at horizontal shift. So again, let's look at some examples here. Let's say I have f of x is equal to x squared. So we know that squared is our basic parabola graph. So I have something that looks like that. If I have, let's say g of x is equal to, let's call it x minus 2 squared. So now, when I was talking about inside or outside the function, before I had what? I had something that was like x squared plus 2, and that meant I moved it up. Now I have the number inside the parentheses with the squared function. So I know it's still going to be a parabola because it's x squared, but what does this minus 2 do? Well, again, let's build a table. So negative 2, negative 1, 0, 1, 2. So if I have negative 2, plug it in there, negative 2 minus 2 is minus 4. Minus 4 squared is positive 16. If I put in negative 1, negative 1 minus 2 is negative 3. Negative 3 squared is 9. So we got some big numbers here. 0 minus 2, negative 2 squared is 4. 1 minus 2 is negative 1 squared is 1. 2 minus 2 is 0. 0 squared is 0. So I'm actually now going to add a couple more positive numbers here. Because really all this did was just give me, what, like everything on the left side of the parabola. But I want to know where's the right side going. So if I plug in 3, 3 minus 2 is 1. 1 squared is 1. And now you can see the numbers start going back up. 4 minus 2 is 2. 2 squared is 4. So this one, what happened? Well, at 2, I'm at 0. 2 to the right, up 0 units. At 1 to the right, I'm up 1 unit. At 0, I'm at 4. And if I go back to 3, I'm up 1 unit. And if I move out to 4, I'm up 4 units. So this function, when I had the 2, well, if I had any number inside, was it due? That's my horizontal shift. And what I would say is this. So I don't know what time of the day it is. Maybe you're watching these videos, you're a little hungry. What sounds good? Pancakes, right? Why pancakes? Well, everybody knows the International House of Pancakes, IHOP, right? So when we are doing shifting, remember pancakes and IHOP. Why? IHOP stands for inside is the horizontal shift, and it's the opposite of what I see. So IHOP. Inside, horizontal shift, opposite of what I see. I see minus 2, which means it's actually a plus 2 horizontal shift, or in this case, 2 units shifted to the right. So again, let's look at another example. Let's say I have h of x is equal to x plus 1 squared. IHOP, inside, opposite of what I see. So now this is going to be negative 1 horizontal shift, which means 1 unit to the left, but it still looks like the parabola. It just got shifted over to the left. So that's how numbers within the function can create a transformation in the graph. And so again, if I put it verbally like we had for the vertical shift, not vertical, horizontal shift. Again, assume C is positive. So to graph y equals f of x plus c, we're going to shift f of x, c units to the left, because it's plus inside, so we're going to move it to the left. And to graph y equals f of x minus c, we're just going to shift the function, the base function, f of x, c units to the right. Again, because there's a minus inside, minus would normally mean left, but because it's inside, we go opposite, and we go to the right. So now, let's look at a combination of the two. So we looked at just vertical, we looked at just horizontal. Now, what if we have a combination? So let's say we want to graph f of x is equal to the square root of x minus 3 plus 4. So, I was talking about these various base functions. So let's review that real quick. When we have x squared, that's what? That's a parabola. If I have x to the third, that's what? That's that sort of snake-looking graph. If I have square root of x, that's what? We're starting at the origin, and it's that sort of fireworks or that rocket shape. And the other one we have is what? The square root of x. And square root of x looks like what? That looks like the V. So make sure you have these sort of in mind, because these will be the base functions we're working with. X squared, x to the third, square roots of x, and the absolute value of x. So let's look at what's happening here. So first of all, our base function is what? Our base function is square root of x, so we know it's going to look like that rocket. We have the minus 3 inside horizontal opposite. So this means this is going to be plus 3 units to the right. And then plus 4, well that's on the outside, so that's my vertical shift. So this is 4 units up. And when we talk about left or right or up or down, it's really talking about what? It's talking about this vertices. So when we had the parabola graphs, it was moving the vertice of the parabola either left or right, up or down. So same thing here. We have the square root function, but where it starts is no longer at the origin. It's what? It's 3 units to the right and 4 units up. So if I graph this, or sketch it, might be the better term, it's 3 units to the right, 4 units up, but it still has that same firework shape. So it looks something like that. And that's it. So we didn't have to build a table. You could. So if this was on an exam and you can't remember, oh my gosh, is this up, down, left, right, I don't remember, no problem. Plug in points and try and calculate it. But if you remember these transformations, you can do a problem like this, within a few seconds, really. 3 units to the right, 4 units up, that's where the square root piece starts. Move it there, and then just draw your tail. So that's it. That's the end of video 1. Come on back, and we'll look at reflecting graphs on the axes.